Hi, on behalf of 24 Hour Answers team, I would like to welcome you to today's lesson. Today's lesson is resistors. In order to explain what exactly resistors are, we'll have to briefly go through conductors and insulators. Conductors and insulators are types of materials that can be found all around us. There are other material types like superconductors or semiconductors and so on and so forth, but they are not important at this moment. Without getting too much into physics and chemistry, the main difference between conductors and insulators is that electrons in conductors can move around freely. In insulators, that is not the case. They are, so to speak, stuck. Of course, the electrons in conductors won't just move around on their own, they need an external electric field for that. Now to move on to resistors. Resistors are made out of insulator type of materials. If we would have a potential difference at the ends of a resistor, some electrons would start to move and we would get an electric current. That electric current is a lot smaller than the one we would get if that potential difference was applied to the ends of some conducting material. The resistance is described as the ratio of potential difference applied to the resistor and the current goes through it, or R equals to V divided by I. We can write this formula in another way. I equals to V divided by R, and that is the Ohm's law. Now, the formula V equals to I times R makes sense only if resistance is constant and independent of the current and voltage. We say this because in real life this is not the case. If we have some current through the resistor, electrons collide with atoms. That in turn heats up the material. At that point, resistance can increase or decrease, depending on the insulating material and its properties, and voltage and current are no longer linearly proportional to one another. In most examples and homework, we will presume that the resistance is constant. If there is a potential difference of 1 volt across the resistor and a current of 1 ampere goes through it, we say that the resistance is 1 ohm. You can see that on your screen. The conductance, or reciprocal of resistance, can be calculated by basically just saying G equals to 1 divided by R, and the unit is Siemens. The resistance of a resistor can be calculated with the formula R equals to ρ times L divided by S. Ρ is the resistivity of the material that the resistor was made out of. Unit is ohm meter. L is the length of the resistor, and S is the cross-section area of the resistor. The reciprocal of resistivity is of course conductivity sigma, and the unit is Siemens meter to the -1st. Like we said, resistance in real life depends on temperature. It would be more accurate to say that the resistivity of the material depends on the temperature. You can see the formula on your screen. ρ20 is the resistivity of the material at the temperature of 20 degrees Celsius. Alpha is the temperature coefficient of resistance. It can be positive and negative. Unit is Celsius to the -1st. T is the temperature in degrees Celsius. That should be it. Thank you for your time. Check out our YouTube channel for more lessons.